So remember, at the end of the day on these graphing equations, you're just going to plug it in Desmos to double check what you think it looks like. Also, you could always plug in numbers, and that'll give you an idea where things match up and stuff. One of the things that's interesting about this is that tangent is actually equal to sine of cosine, sine over cosine, I mean. So if I wanted to figure out, for example, if I wanted to figure out the x-intercepts, I would just figure out where sine equals 0, right? So I would think, well, where does 4 sine of 2 theta plus pi over 3 equals 0? And that would be my x-intercepts. Stuff like that. But remember, this is written in the form a tangent 2 theta. Oh, wait, let me put the general form. Bx plus c. And so I am looking for, on the final exam, for you to tell me what a, b, and c are. So a would be 4. B would be 2. And then c would be pi over 3. Remember that tangent, the period, is actually pi over b. For sine and cosine, it's 2 pi. But for tangent, it's just pi. The 2's cancel out. So, actually, it's a little more complicated than that. But, so we get pi over 2. That's the period. And then the phase shift is just c over b, which is pi over 3 divided by 2, which is pi over 3 times 1/2, or the phase shift is a positive pi over 6. Which is interesting because I noticed that the software labels everything as pi over 4. So now, if you have this written on your paper, what I want you to do is think in your brain, all right, well, now my period is pi over 2. Now, tangent itself normally goes from pi over 2, negative pi over 2, to pi over 2, and it has a period of pi. But now, the period will be 1/2 that. The 4 is going to stretch that bad boy vertically. Okay, so now the lines are going to be less curvy. Also, this is going to shift it a little bit. All right, so the phase shift has an impact on where we shift it. But at the end of the day, you can graph it. So now graphing it in Desmos and then having to sketch it by hand, that's the hard part for you guys. So just type in the equation as you see it. We would say y equals 4 tangent in parentheses. Now you can't use theta, you have to say x instead. And whenever you want to put pi in Desmos, you just type in pi. By the way, I had an interesting conversation with a friend of mine that was Greek, like from Greece. Like his great-great-grandfather was Greek. Like, no, he was literally grew up in Greece, lives in Greece now. He said it's actually pronounced P. Right? So remember that our alphabet is based on the Greek alphabet, and this is the letter for P. Anyways, interesting tidbit. And there you go. That's what it looks like. But I want to know where to draw the lines and stuff. So I'm going to go in here. Remember that my graph had pi over 4 increments. So this is what we call, it's step, but another fancy math word for that is incremental. Okay. And if I look at my graph, oh, I did it again. Let me pull my graph back up. I'm going to set the window on my graph. I'm basically going to try and make my graph look like this graph. So notice that the y-axis goes from 6 to -6, and this goes from like pi over 2 to a little bit past 2 pi. All right, so we got to do some math on that. So let's go negative pi over 2. Now, what is 1/4 pi past 2 pi? 9 pi over 4, right? Clearly. All right, and then our y-axis, we just want to go from -6 to 6. Enter that bad boy in there. And now I've kind of got the same graph, and let me move my beautiful face out of the way. I've kind of got the same graph that we have here. So where does this look like? This I'm gonna do a little thing here. We're gonna try to figure out where the asymptote is. So I'm gonna say x equals pi divided by, and I don't know what the number is, but I'm gonna say a. Oh boy, that's not good. Let's do like we'll do p. But then I want to put in the, oh, won't let me put in a slider? Well, that's not fun. Huh. That's interesting. Wow. So remember that the period, here's an easier way to do it. The period is, based on our notes, pi over 6. What's 1/2 of pi over 6? Pi over 12. So that's where it gets complicated. Let's just do these zeros and we'll eyeball it. I don't know. I think it's too early in the morning for you guys to convert fractions that involve pi. But basically, I'll explain what you would do though. So you would say pi over 6. Like for example, if I wanted to know the middle of this, you could take the average too, right? Like I could do 5 pi over 6 plus 4 pi over 3, and then divide it by 2, and that'll give you the vertical asymptote. But let's just do the zeros, and then we'll eyeball it. So I'm going to take a sketch of this. I'm going to copy this, and then we'll sketch it in. So pi over 6 is just a little bit before negative pi over 4. So negative pi over 6 is just a little bit before that. Pi over 3, think about this as pi and go about 1/3 of the way. It's just a little bit past here. Then 5 pi over 6 is like 1/6 before pi, so it's about right here. And then 4 pi over 3, that's a little bit past here. And as we start to put these in there, you could almost eyeball about where it would be, because they would be equidistant, right? They would be about the same distance apart. And then in the middle of those are where we're going to have our asymptotes. So we're going to have, that's why I said we could just eyeball it. So this is our vertical asymptote. It goes right through the middle of those dots. Try to make your line straight. If you have rulers, that would probably be helpful if you were to do this on paper. Today Friday. Okay. So my first one kind of comes in from here. And remember that 4 kind of pulls it, it stretches it vertically so it's not as curvy, right? This one, same thing here. We're going to kind of and that's it. Any questions on that? Oh, we got to extend the lines though. I'll zoom in a little bit.